Okay, we have the Geometry C exam review. So let's start with number 1. The vertices of a rectangle are as follows. A translation maps R onto the point -4, 2. So what's that saying is the original point, or the pre-image, is -5 for R, and R prime is -4, 2. So we have to figure out what vector, or how is this changing, how is this being translated. So how do I go from a -5 to a -4? I've added 1. So that really means a +1 is 1 to the right. A -5 turns into +2, means I've added 7, or 7 up. So I know that my translation is +1, +7, which that happens to be the only option here is B. But what they're asking here is, what would the coordinates of U prime be? So U is -5, 1. If I applied this vector, -5 plus 1 gives me -4, and 1 plus 7 gives me 8. So again, finishing the coordinate. Number 2, what translation rule can be used to describe the result of the composition of this translation as well as that one? So we're just combining these two vectors or these two translations together. If I've gone 5 to the left and another 7 to the left, that really means I've gone a total of 12 to the left. If I've gone 3 down and another 1 down, a total of 4 down. So which of these vectors represents that? B. Number 3, the vertices of a triangle PQR are as follows. We want to reflect, R for reflect, on the line y equals x. So what is the coordinate rule for reflecting on the line y equals x? I change the order of the coordinates. So -8, 6 becomes 6, -8. 1, -3 becomes -3, 1. -6, -3 becomes -3, -6. Which would give us an answer of B again. Number 4, the dashed line figure is a dilation image. What I wanted to show you here, I already put on your page that it's 3 times the size, because they didn't use 0, 0 as the center, and we always do. So normally, how would we figure out if this is an enlargement or a reduction? We're multiplying coordinates. So anyway, it's 3 times its size as an enlargement. So B once again. Number 5 is the area of a parallelogram. So how do we find that? Base times height. The biggest thing we have to remember is that our height is always perpendicular to the base. So in this case, my base is 36 and my height is 33. I do not need 40 to help me with this calculation. So 36 times 33 gives me 1,188 inches squared. Okay, number 6. So here we have a triangle. So the formula for the area of a triangle is 1/2 times base times height. So just like before, I'm looking for my perpendicular height, which is perpendicular to the base. So that's going to determine what I'm using. So area is 1/2 times 4.4 times 2, which ends up giving us A, 4.4. Number 7 is a little bit tricky. So here we have a parallelogram. So we know that the area of a parallelogram is base times height. So when I'm looking at 27, compared to that base, h would be the height that goes with it. So 27h would be our area. Well, that's not going to help me solve for h. What they want you to realize is they gave us a second way to calculate the area of the same exact parallelogram. I know that 36 and 24 are also a base and height. They are perpendicular to each other. So 36 times 24 would also give me the area to this parallelogram. So 36 times 24 is 864. So if I want to solve for this height, I would divide by 27. And I get h is 32. Alrighty. Number 8, find the area of an equilateral triangle with a side of 10. So here I already drew a little picture. Equilateral means all three sides are the same. Hopefully what you realize is that this is considered a regular polygon. So if I want to, 1/2 times perimeter times apothem. So we have to solve for this lovely little apothem here. So if I break up my triangle into the central angles, 3 triangles, 360 divided by 1, 2, 3 is 120 each. But when I drop my apothem down there, I'm actually breaking it up into 60 and 60. So when I'm solving this right triangle, I'm thinking about this is 5, the whole length's 10. My apothem, and this is 60 degrees. So, the tangent of 60 is equal to opposite over adjacent, which happens to be our apothem. So I'm going to cross multiply. A times the tangent of 60, and 1 times 5 is 5. In order to get A, I'm going to divide both sides by the tangent of 60. Now you want to make sure that your calculator is in degree mode, and I'll remind you that on your exam. So 5 divided by the tangent of 60 is 2.88, so I'll round that to 2.9. So are we done with the problem? No. I still need to find the area of that equilateral triangle. So I know that 1/2, my apothem is 2.9. I also need to calculate the perimeter. So the distance around this equilateral triangle is 30. So that's what I plug into my formula. So 1/2 times 30 times 2.9 gives me 43.5. Oh no, I'm looking at these answers and I don't have one that's 43.5. Well, let's make sure one of these are not equivalent. So if I press 25 square root 3, yay, it's 43.3. Number 9, find the circumference of the circle. Circumference is diameter pi. So if my radius is 18, then my diameter is 2 times that amount, or 36. So circumference is 36 pi b. Number 10, another regular polygon. I drew a picture at the bottom. Find the area of a regular hexagon, so we have 6 sides there, with an apothem of 17.3 and a side length that's 20 miles long. The good news is we already have all the information I need to plug into this formula. So I do not have to use trig on this one. If each side is 20, 20 times 6 is 120. And my apothem is 17.3. So 1/2 times 120 times 17.3 gives me 1,038.